Hello and welcome to the Journal. I'm Steve Kendall. As winter turns into spring, we thought it would be a good idea to get an update on what's going on in Lake Erie. It's contributing watersheds, including Sandusky Bay. And our guest is Dr. George Bullerjahn, who is a distinguished professor of biology at Bowling Green State University and also the director of the BGSU Great Lakes Center for Fresh Waters and Human Health. Dr. Bullerjahn, thanks again for being on the Journal with us.
No, it's great to be here and give updates as they happen yearly. So it's a pleasure.
Yeah, and one of the things that has happened too, you know, obviously what goes on, your focus, the main focus right now is Sandusky Bay, but when people think about Lake Erie, that's the name that they recognize the most. But the work that you do and you have been doing wasn't diminished by the pandemic. We just didn't hear as much about it because the pandemic dominated the news every night. So talk about what you've been doing since we last talked, which was June of last year. So what's been going on with the Center for Fresh Waters and Human Health?
Well, the state has sort of given us Sandusky Bay as our main target area, although we do some other work around the islands and in western and in open waters of western Lake Erie. But one thing that was might be a surprise to some is that our activities really were not curtailed by COVID at all. It's a lot of our field work, of course, is outdoor activity that was considered to be safer. And so we still made our regular weekly trips out onto the lake and the bay and got the samples that we needed. Our lab work was slowed down a little bit because due to restrictions of the number of people that could be in the lab. But really, we kept up with all our assigned duties for the Ohio EPA and Ohio Department of Natural Resources.
Yeah, now, go ahead, I'm sorry, go ahead.
Yeah, well, one thing that was surprising though, is that we've been following a toxic algal bloom, a cyanobacterial bloom in Sandusky Bay for years. And then starting in 2019, the bloom was there, but was kind of a little bit less intense. And then it completely disappeared in 20 and 21. And so basically the health of Sandusky Bay is much, much improved. And that's the good news. The bad news is that we're not really sure why. And I have a couple ideas, but that I'd be happy to share, but we're still working on that.
Yeah, because the path has been, we've obviously been talking about algae blooms for, you know, probably, well, more than a decade really, and well beyond that. So when you look at Sandusky Bay and see this change or this lack of an algae bloom, what is your thought? What are your thoughts on that? Is there speculation on what may be happening there?
Well, yeah. So the things we have to do is look at whatever is different now than was prior to 2019, and so there are two things. One, we're in a period of higher water level, and when you have higher water level, it's more difficult for winds to disturb the sediments, which are full of nutrients, and so we're not seeing as much nutrient regeneration out of the sediments that might stimulate a bloom. That said, if you look at the overall levels of nutrients and look at the water chemistry really isn't that different than it was prior to when the blooms were happening. And so it could be water level, and so hydrologists, which is not my area, are actually doing some modeling, looking at how sediment will behave at a higher water level at different wind intensities. So that's one thing that's being explored. The other thing is that the loss of the bloom or the decline of the bloom is temporarily linked to the removal of the Ballville Dam of the Sandusky River. And so that could have changed the nutrient and hydrological profile of the whole system. And so now we're looking at sediments that were obtained above the dam before the dam came out to see if perhaps the reservoir upstream from the dam could have been a incubator for the bloom that then got discharged downstream. So there are things we're looking at, but we don't have an explanation for it. But right now, the water quality in Sandusky Bay is much improved, and that's great. But it'd be great to know why, because if we can come up with a mechanism by which a bloom stopped happening, then that's something we could probably use to explain and drive management efforts elsewhere where these blooms are happening.
Yeah, so, as you said, it's something that's surprising because the trend has been the other way mainly. And yeah, it's interesting though that just in changing that particular thing, taking that dam out, of course, changed the flow of the river, changed the flow of sediments and things. So that's it would be interesting to see if that would be, if it was that simple, I guess that would be a great thing, but
Yeah,
yeah,
and things are never that simple.
never that simple.
But that's what we're working with now.
Yeah.
So, and when I'm on the show again, I can tell you whether we think we're right or we think we're wrong.
Well,
later on.
and the good news is, as you said, if you can find what that mechanism is, then it can possibly be applied to these other areas. We have a mechanism to say, oh, look, we can fix this in a way that we maybe weren't aware of before. So that's good news. You talked about doing some work out in Lake Erie. Anything new in that front, or anything that's you've surprised you there?
Well, we're still looking at viral activity on blooms. I think maybe last time we were reporting that if you have a cyanobacterial bloom, there are times where you see these big pulses of dissolved toxin that enter the water treatment plants. And that's due to the fact that we've shown that this is due to viruses which attack the cyanobacterial cells and then release intracellular toxin into the water. And normally a water treatment plant, the best thing they can do is filter out all the cells of the bloom using large sand filters or flocculation techniques. And if you can get rid of, if you can just, basically precipitate out all the cells, you're getting rid of all the toxin, or the vast majority of it. Under viral attack, though, the toxin enters the dissolved phase, gets around these filtration systems. Then you have to treat the water with chemicals in order to make it safe to drink. And so we're developing analytical techniques for viral activity so that perhaps we can assess when viruses are abundant and could be doing this during bloom periods. So that's our main focus right now with respect to the lake at large.
Yeah, and it's interesting as you're talking about water levels, because the lake levels have been all over the board the last number of years. They've been high some years, low some years, so that's another variable that you have to take into account as you do this as well.
Yeah, I know, and you really need data sets going over decades where you're tracking these blooms, and we don't really have the complete picture over decades and decades of the abundance of the blooms relative to high and low water. So putting water level as a factor into the whole equation is still an uncertain thing.
Right. When we come, go ahead.
And the role it's playing. So,
when we come back, I know the other thing you talked about too is obviously you've been studying the lake in all seasons, but winter, of course, is one that you've been focusing on just recently. When we come back, we can talk about the winter study of the watersheds and the water bodies that you're looking at. Back in just a moment with Dr. George Bullerjahn, Director of the BGSU Great Lakes Center for Freshwater and Human Health, here on The Journal. Thanks for staying with us on The Journal. Our guest is Dr. George Bullerjahn, Distinguished Research Professor in Biology at Bowling Green State University, and also the Director of Bowling Green's Great Lakes Center for Freshwaters and Human Health. We're just coming into spring now. You were doing something over the winter, and I think you called it winter grab. So talk about what winter grab is, and I know it's a multiple institutional sort of situation, but what's winter grab?
Well, it's a winter grab is a project which is actually initiated and led by a group at the University of Minnesota Duluth. And what we all agreed to do is to have folks from all around the Great Lakes sample the Great Lakes through the ice, under the ice, around the ice during the winter time to get an idea of really what's living in the lake at these during this supposedly dormant period. Now, my colleague Mike McKay and I went out on icebreakers about over 10 years ago, and thinking we wouldn't see much, but in fact there are huge growths of diatom algae, good algae that form in and under the ice, and these are very important for the food web. And we subsequently showed during a high ice year and a low ice year that the algae composition changes markedly. So the kind of algae that grow in a high ice year, which is sort of typical for the past, is different than what's growing in a low ice year or a no ice year, which is more typical of the future. And so that begs the question, what does that do to the food web? Diatoms are important in supporting a food web leading up to the fish that we catch. Are there disruptions in the food web as a consequence of a low ice year? And so the winter grab really expands the reach beyond Erie. So it's a comparative study of all the Great Lakes, in the winter time, and sets a baseline for what the lakes are going to become. If we do this on a yearly basis, we'll get a really good data set which shows how the lakes are changing as the climate changes. We've seen a decline in, we've seen a 70% decline in ice cover over the past 50 years. It's really, really striking. Lake Superior is one of the fastest warming lakes in the world. And so the more we understand what's happening in the wintertime, when 30 years ago people said nothing's happening, when in fact we know there's a lot happening, the better we understand this, the better we'll be able to predict what's going to happen in the future with climate change.
Yeah, and right, as you said before, this will start to give you that decades of data that you'd like to have in some of these other situations. When you see this, and I guess as you work with people for all through the Great Lakes, these different institutions, do you see any similarities of things going on, say, in Lake Superior and Lake Erie? Is there any, because obviously the water eventually flows through and ends up in the St. Lawrence Seaway and out to the Atlantic, the Niagara River, all of that. Can you actually track anything from other lakes into Lake Erie, or are we still, that's still a little dicey?
It's a little dicey, and Lake Superior is so different in terms of its depth, in terms of its physical characteristics, in terms of its chemistry. It's very much lower levels of nutrients than Lake Erie. I mean, nobody, comparatively, well, 25 times more people live in the Lake Erie basin than do in Lake Superior.
So that...
And Lake Erie has 1/20th the volume. And so the human impact, if you just do the arithmetic, is about 500-fold greater on Lake Erie than it is in Superior. So, but really, we don't know what's happening in Superior and these upper lakes in the wintertime to the extent that we do from Erie based on the work that McKay and I were doing a decade ago. So I'm just so excited to see what we find. Labs from all over the Great Lakes Basin were given a different assignment for a different particular kind of measurement. So we're going to have, chemical data on the water, genetic data on the microbes and algae that are living in the water, and all sorts of physical metadata on all the sites. And putting it all together is going to be a great comparative study. It will be a snapshot, but if we keep the snapshots going every year, we'll have a pretty good. We'll get some trends that we can find as the lakes warm over time.
Yeah, because this is really a big mosaic, actually, trying to get all of those pieces connected to each other and see if there are any, and if there is a connection, I guess, too.
And the efforts that were made to make sure that everybody got the same sampling equipment to be measured exactly the same way. I mean, I really have to give credit to Ted Ozerski and his grad student Kirill Shtapov, because they coordinated everything perfectly, and now all the samples are where they're supposed to be in the labs that are doing the work they're supposed to be doing, and it's just was a wonderful collaborative effort. And when things come together like that, it's really a lot of fun.
Yeah, well, and the other aspect too is there has been, we would like to think, a greater emphasis on providing resources for your kind of research and all of these research activities. The focus on the Great Lakes is seemingly, from someone looking from the outside, has been much more intense than it was maybe 20, 30 years ago.
It's much more intense, and it's also much more collaborative. One thing it's been a real pleasure to work with all the different folks that live everywhere else in the lakes. It can be that scientists can be very competitive, but this is an area where just people sit around and decide what we're going to do, and we made it in just a few months, came up with this really broad effort very, very easily, and it's just very gratifying to see something like this come together.
Now, and I know that when you look at Lake Superior, some of the lakes you said, of course, it obviously doesn't have the ice coverage that that Lake Erie does things like that. And I was kind of surprised. You said the ice coverage was 70% less than we'd seen in the past, and obviously that's one more, as you said, one more variable now to deal with, that the lake doesn't freeze the way it did 10, 20, 30, 40 years ago.
Right. I mean, it still freezes, but the freezing period is much shorter. The extent of freezing is less, and you put it all together, and there's been a really huge decline in the amount of ice. And you know, Erie freezes the most surface area wise because it's so shallow and loses heat more easily. And Superior, you know, you typically see in the nearshore areas around the Apostle Islands and in the bays, but
not out in the open space.
The middle of the lake is typically ice free.
Yeah. Well, and you know, besides, as you've talked about this work around the Great Lakes and the collaboration too, when we come back, we can talk about the fact that this is a global effort as well. It isn't just about North America, the United States, Canada. This is something that basically goes all around the world wherever there happens to be water. So when we come back, we can talk a little about what you're going to be participating in the future around the world as well. Back in just a moment with Dr. George Bullerjahn from the BGSU Great Lakes Center for Fresh Waters and Human Health here on The Journal. Thanks for staying with us on The Journal. We're talking about water around the Great Lakes and all its tributaries and contributing streams and rivers and bays with Dr. George Bullerjahn, Distinguished Research Professor of Biology at Bowling Green. We talked about the fact too that this has expanded beyond Lake Erie. You now work with people from all over the Great Lakes, but and I know that when we've talked in the past, you're working with people from all over the world, and you've got a lot of something very specific coming up. But talk about the global aspect, and what you're going to be doing then over the next few summers in your spare time when you're working on this whole water issue.
Well, we've been funded to do projects in Lake Victoria in this Gulf, the Nyanza Gulf, which extends into Kenya from Lake Victoria. And so we're taking a number of students to Africa to work with a Kenyan cohort to study the cyanobacterial blooms which happen in the Gulf, in this Gulf and in Lake Victoria. So this is very useful for us because the blooms are caused by an organism similar to that which blooms in Lake Erie, but and it produces the same suite of toxins, this microcystin toxin. But of course, Lake Victoria, being in equatorial Africa, never freezes,
right? And
so there's the lake characteristics are very, very different. It's a shallow lake, never freezes, or it's shallow where we're working, and so it'd be interesting to see firstly what the impacts are on the populations there. How are they dealing with the toxins? Are there better ways to detect toxins? And one of the projects we're bringing with us are comparing different toxin detection technologies, such that people in water treatment plants and the general public can be best informed about the threats afforded by these blooms. But secondly, really, does the bloom behave differently in a lake in which it doesn't freeze? Is there what kind of seasonality is there, if any? Whether it's just there all the time, are there patterns in toxicity? And so, you know, we can take a look at data sets at the Kenyan Marine and Fisheries Institute there at Kisumu, Kenya, and see what are the overall patterns. Are there things that they see in Lake Victoria which parallel things that we're seeing in Lake Erie or not? And so I think it opens the door for a useful comparative study about toxic microcystis blooms as they occur elsewhere in the world. And it's going to be a great educational experience for the students we're bringing over. We're bringing 10 graduate students with us, 3 of whom are coming from Bowling Green State University and 7 from other institutions around the country. And they will be working with a cohort of 10 Kenyan graduate students and working on projects that they developed, you know, of course, vetted by faculty, me and a few other faculty. But and also generating metadata, which is of use to other people. So at the same time we're going to be there, there are going to be satellite overflights over the lake, and we can be providing data to people analyzing the satellite data, saying, okay, we know there's this many micrograms of chlorophyll per liter in the water. They can calibrate sensors on the satellites at the same time. And so we can get we've done this with Lake Erie, but we can also refine remote sensing data for Lake Victoria, which hasn't been done to the extent it has been for Lake Erie. So I think it's going to generate data for a lot of folks that's of good use.
Yeah, and I think you said too, you know, obviously you're gathering data, you can then compare that to what's going on in Lake Erie. Obviously, our hope is that Lake Erie never becomes close to what Lake Victoria is in terms of water temperature and things like that.
Right.
But
it shouldn't.
That would be rather severe climate change, I guess. But as you said too, though, the more information you have and the different people you have looking at, different ideas, different faces, different thoughts on it, hopefully helps us solve our issues with Lake Erie and the Great Lakes in general. When you look at what you've been doing, what's coming up now as we get into the spring now, because obviously, as you said, you've been busy all year. You're out there pretty much all the time. But as we get into the warmer months, that's when you really start to put a lot more activity out there, and sensors and buoys and all other things to track all of this. So talk about what's going to be happening now over the summer.
Well, this is sort of where we are now, is sort of like where baseball is. Pitchers and catchers are reporting, and spring training is getting going, and you know, so we're getting all our equipment ready to deploy. We have a buoy that goes out in Sandusky Bay. We have a bunch of sensors that we have to prepare to go on to another node on the Sandusky Bay Bridge. We're making, you know, we take our research vessel out of winter storage, get all the sampling equipment cleaned and ready to go. And so that's what this time of year is for. And with the goal of getting all our instrumentation in the water by the 3rd or 4th week in April. And then we start in earnest sampling for Ohio EPA and ODNR in May. And then it's, you know, we do everything every week until September or beyond. But this is the getting ready time of year is, you know, it's busy and full of surprises, especially with you know, supply chain issues. Can we get bottles?
Right.
Yeah,
well, I was just going to say, if you're trying to get new technology out there, that could be problematic right now. But so far, you haven't experienced any real difficulties yet. Then,
we do see some issues with supply chain. I mean, you know, just getting simple stuff. You know, gaskets. You know, little parts. You know, so we can. You know, we haven't been hampered too badly by it. But this is the time of year where I'm just ordering stuff like crazy, with the hope that it'll get here by the time we need to use it.
It'll arrive eventually. Right. Is there anything different that you're going to be doing that you haven't done in the past out there this year? Something new, another piece of this, another layer, another angle?
I think we're going to be keeping a closer eye. Really, not too much. I think we'll be keeping a really close eye on the bloom in Sandusky Bay, or lack of bloom. Right. And just really get down to what other algae are growing there, you know, and get a much better handle on the taxonomy of what's in the water. I mean, we're doing that, but now that we know, we really want to know in detail what's growing in place of the bad guys.
Right.
So,
right.
But you know.
Yeah, it's interesting because that's really good news, but it's like, okay, but is this a long-lasting thing, or is this is this just a temporary? Is there some, as you said, maybe just taking the dam out? That's a temporary thing, really. I mean, it will be consistent, but will
maybe
it?
Not. Yeah. I don't know. I can't tell you what's going to happen this year, so I can't wait to see what does happen.
Yeah.
I can't say that the last 2 years I've been getting emails from boaters saying, "Hey, the bay looks so much better. What happened?" You know, and I'm not going to take credit.
Oh, I
for it.
thought you were going to say, oh, you should. You should. Well, of course, we've been out there working. Yeah, I got it.
No, I guess I could, but I'm not.
Okay, all right. Well, we'll let you take credit the next time we talk. You say, hey, here's how we improved the lake this year, and it's all on us. We did it all ourselves. No, just kidding.
Yeah, but if the balloon comes back, then it's torches and pitchforks after me. So yeah.
Yeah. Well, hey, Dr. Bullerjahn, thank you again so much, and good luck with the research out there this year. We look forward to talking to you because obviously, what goes on in Sandusky Bay, Lake Erie, all the tributaries, the Great Lakes in general, affects everybody in Ohio and of course around all the Great Lakes states. So we appreciate the work you do, and we'll get back to you again, and we'll see where we stand in a few months then.
Great. Thanks for having me.
Yep. And you can check us out at WBGU.org, and of course you can watch us every Thursday night at 8 p.m. on the Journal on WBGU PBS. We will see you again next time. Good night and good luck.